Good morning to everybody, and welcome to our webinar about the Oppent mobile robots for healthcare market. In this session, I have the pleasure to give you a short introduction of myself and Oppent organization. Then I will present an overview of different models of mobile robots, their scope, benefits, and technical features, without going too much in the details due to the limited time we have. If you have any question, please forward it, and then we'll be glad to answer and assist you. So let's start. And I hope you enjoy it. First of all, this is me. My name is Marco. I am the sales director and one of the stockholders of Oppent. I am in the company since 21 years, and I have a very long experience in mobile robot application, especially for healthcare market. Here we have some key information about Oppent. The company was founded by my father in 1960 in Milan, in Italy. So this year and exactly in these weeks, we celebrate our 60th anniversary from the foundation. Today we have more than 100 employees. We supplied more or less 120 hospitals, and we are present in 15 countries, directly or in cooperation with some distributors. Oppent is not only a manufacturer of mobile robots. We have another business unit that designs and produces pneumatic tube systems, and an automatic system for the collection of waste and linen. Even this last system is based on a pneumatic concept. This is a map of our locations. Our headquarters is in Milan. Then we have 4 branches in Spain, in United Arab Emirates, in Turkey, and in Germany from this year. And finally, we have a network of distributors that cover USA, Brazil, other countries in Europe, Russia, China, and Singapore. This is our manufacturing plant, fully dedicated to mobile robots design and construction. We present on the right also some data about the production capacity. Our forecast is to manufacture up to 110 mobile robots in 2021. Then here we have an overview of our references. We delivered or will provide mobile robots in several countries as Italy, Spain, France, Norway, Switzerland, Turkey, Saudi Arabia, and China. Now, let's talk about mobile robots. We'll go through the different models, the transported materials, benefits, and some information about the market. We can divide our mobile robots range in 2 main groups. On the left side, we have the cart robots that are suitable for hospital trolley handling. And on the right side, we have the collaborative robots that are dedicated to the transport of small items, or in this case below, are dedicated to the handling of beds with patients on board. Here on the left, we have a list of all the goods plus beds with patent that can be transported with our mobile robots. And on the right, the different services and areas that can be connected each other through the mobile robots. There are a lot of advantages using mobile robots. The first one, a decrease of cross-contamination risk because people are no longer involved in transporting material. The second, it is also demonstrated a reduction of infrastructure and trolley damages, as well as reduction of injuries to personnel. Then we have the payback period. The return of investment, including maintenance costs, is very quick. Automatic transport is available 24/7. Then a better organization of material flows is possible. Then personnel can be more focused on patient needs. And finally, the hospital has the opportunity to increase the level of reputation thanks to the installation of a very advanced technological solution. Here I focus about the market of mobile robots that you can appreciate looking at this data and graph. So we are talking about the application of a solution that is in continuous increasing. Now, let's talk more deeply about the cart robots. So the mobile robots, about the mobile robots dedicated to the handling of hospital trolleys. We are supported by some videos. In the first one, you can see how the mobile robots manage the trolley in sending and receiving stations. When we have a loading phase, the mobile robot comes in front of the cart. It calculates the route looking at the wheels through the front laser, and then it stops thanks to a feedback done by a couple of magnets that are installed under the trolley basement. Then the cart is lifted up and it starts its journey. The delivery phase is also very simple. The mobile robot reaches the destination and unloaded the trolley, lowering the platform. And so the transported is completed. Few words about the navigation system. That is a natural navigation. What does it mean? The system works without a fixed installation into the floor, as for example, wire guides, magnets, transponders, etc. So we don't need such items. Then it means that all the mobile robots have a building map on board generated by a laser scanning survey. On this map, there is also the layout of the system. The navigation was combining in real time a first information that comes by some encoders mounted on the wheels that measure the travel distance with the information that comes from the laser scanning of the environment. The onboard lasers look at some determined natural reference point as doors, segments of wall, pillars, etc. Then we don't need other infrastructure. This also means that the installation is not invasive and the system is very flexible in case of modification or extension. This method permits to have a very accurate capacity of positioning with minimum tolerance that permit the system to work in narrow spaces. Then, as we are seeing now, here the system has also the capacity to avoid an obstacle. It is important to say that there are some restrictions about the success of this way of work. For example, spaces must be available. Then the layout analysis, the size of the mobile robot we are using permit to evaluate if and in which part of the layout this way of work makes sense. The system is also logically interconnected to the doors along the path to open them and then to close them automatically, as we can see. Usually the hospitals are multi-level buildings. Then the system is also interconnected to the elevators to reach all the floors. We have also an example that is coming of stopping position. Okay, here we are. In case of fire alarm, when a normally open door closes, the vehicle can stop. And finally, the system layout includes also the automatic charging stations that are dedicated to mobile robots. We have the capacity to customize our mobile robots in order to meet as much as possible specific requirements by the customer. This is possible because we have an inner R&D department that has the capacity of customization and continuously improve our mobile robots. We also pay attention to the aesthetic design, even to have a common design between the different models. Anyway, here we have 3 examples as reference: Model 1, Model 3, and Model 5. You can see that there are different sides, different payloads, and different requirements about the substructure of the trolley. Anyway, as I said some adaptations are possible case by case. All these models respect these features, these main features, about the position of the wheels, the capacity to have some performances and movement possibilities in both directions, and the capacity to rotate around its axis. Then, for your information, we have also already designed and installed in industrial application mobile robots that are fully omnidirectional. Then some information regarding the safety features. There are a couple of lasers on board that create a safety zone with two fields, the yellow one, alert, and the red one that stops the vehicle. Field size automatically change depending by the vehicle speed. We have another video here to show that the location of the lasers allow to check the wall perimeter, even if there is a trolley on board. Then this makes the mobile robot very safe to work in the same environment where also the persons walk, and not only in restricted areas. In these examples, you can see how the mobile robot detects the persons that are coming from different angles. There are other features, safety features, and some of them are also mandatory as per safety rules. For example, there are two emergency buttons to immediately stop the mobile robot. We have also luminous signals on board in order to inform the direction that the mobile robot is about to take. And there is also a device on board to issue vocal warning messages in the local language, and a sensitive profile to detect something under the laser scanning quote. We are talking about something lower than 3 centimeters. Now we have a focus on collaborative robots. We present the Evo cabinet, that is a mobile robot with an integrated module suitable for the transports of small items. It has exactly the same navigation system than EvoCart, and it can be integrated in a fleet with EvoCart. Also, the safety features are the same than EvoCart. The onboard cabinet can have a control access with a RFID reader. And in this case, we have also an onboard touch panel that is used to address the transport of the items to the desired destination. Two last examples about collaborative robots. On the left, the Evo Cabinet Mini is just a smaller version than Evo Cabinet we saw in the previous slides. And Evo Bed is a new mobile robot dedicated to the bed with patent handling. It is under development and it should be ready for the market in 2021. The design of this machine has been thought to help the nurses to transport the beds with patient on board. The use of the machine is thought to be semi-automatic inside the hospital room. The nurse can load the bed by a joystick. We can note that this machine is designed to be suitable with a different model of beds. Once the machine with bed on board is in the corridor, the automatic navigation can be activated. So now we are in the corridor. So the automatic navigation can be activated in order to simplify the nurse activity that can be more concentrated on patient assistance. Also, this machine has all the other features in terms of navigation and safety we have on EvoCart and Evo Cabinet. Okay, let's talk about the system interfaces. By this graph, we represent several ways to interconnect the devices as doors, elevators, trolley washing machines, roller conveyors, if any, and so on. The mobile robot system requires a Wi-Fi network in order to permit a communication between each mobile robot and all these elements. The system is controlled by a central software that, in few words, receives the requests of transport, assigns those requests to a mobile robot, and manage the traffic. In the next slides, we can see some screenshots of the software. Here we have a view of the layout. A more general view, 3D view of the layout as well. A detailed information about the status of some transports. And also some examples of statistics about the daily work of the system. Also in this screenshot we have other examples of statistics. One of the most important process during the study of a project is the fleet calculation. Each project starts by the analysis of the expected material flow that can be estimated in case we are in a building under design or under construction, or should be very well known in case we are in an existing hospital. First of all, we do some calculation in order to identify a quantity of mobile robots that should be suitable for the application. We also define the kind of battery, and then we check the functionality through a simulation in order to have a very accurate approach to the project. So that's all. I would like to thank you very much for your attention. As I said, we are available for any further information you'd like to know. Our time is about to finish. So have a good day and stay safe.